Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform where exactly you prepare for your aspired examinations, that is GATE and ESE. So let me check it. Okay. So again, I welcome you all. So before starting, let me give you the brief introduction about myself. My name is Vidyapati Kumar and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University and my specialization was production. I worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and I'm the author and co-author of various research papers publication of national and international journal of repute. You can follow me at unacademy.com at the rate of v.ksir, where exactly I am teaching the strength of material and which is a full course for GATE 2021. So you can follow me. So whenever I will be posting a new videos, you will be getting notified. So basically this session will be more focused on numericals of resistance welding. So we are going to see whatever the concept we have seen about the seam welding, about the spot welding, about the projection welding, and we are going to apply this concept here. Okay. So if you haven't downloaded the Unacademy Learning app, download the Unacademy Learning app, where you will get the opportunity to watch free classes. So free live classes would be there, in which I am teaching the strength of material, and there is another class that is known as plus subscription. Once you are taking the plus subscription, then you will choose you will get the to attend the paid classes. Okay. So the benefit of the Unacademy Learning app is that you will have the daily live classes, so you got the opportunity to interact with your educator. So at the same time, you get your issues resolved at there whenever the online classes is there. Courses are very much structured in nature, tests and quizzes you can give, and the unlimited access of the course content materials. There is a plus subscription in which there is 100% completion of the subjects would be there, 100% course completion would be there, daily live classes are there, courses are very much structured in nature, tests and quizzes you can give, unlimited access of the materials is there, PDFs will be provided. These are the benefits of the plus subscription. Moreover, there is another subscription in which you will get all the benefits of the plus, as well as you will get the benefit to choose personal coach. So like one-on-one coaching would be there. So for whenever you will be in any doubt, or you need a guidance, you need a mentorship, you can choose the personal coach, and that coach is liable to help you throughout your preparation of GATE and ESE. There is another feature that is a study tracker. That a study tracker will like track your study, plan your study, whatever exactly you are doing the mistakes. It will evaluate your progress, and these things would be given quantificatively by the personal coach. So based upon that, where exactly you should improvise on your routine, what exactly you should do, so these things would be given in the study tracker. Moreover, a lot of question and answer practices questions would be given to you, so that mock test, practice test and question test would be so much, entire thing would be there that you do not have to refer anything else apart from these materials. So these are the top educators of the Unacademy, as well as Unacademy has different batches for GATE and ESE for almost all the branches like mechanical, civil, electrical, electronics, production, and industrial, and so on and so forth. So if you are planning for a plus subscription, you can always go for 1 month is around 5,000, for 12 month for 3 months it is 12,500, for a 6 month it is 20,000, and for a 12 month it is 25,000. So in whichever the plans, if you are purchasing, use my code SIRVK, SIRVK, you will be getting a 10% off in each of the plans. Suppose if you are planning for a purchase of 12 months plan, then it will be costing around 25,000. But if you use my code, then again you will get a 10% off, and the discounted amount would be 22,500. Apart from that, if you are in second or third year, you can always go for a 24 months plan, so that your all the doubts would be cleared and your completion of the course would be there for the BTech as well as for the GATE and EAC. So this would be cost around 30,000, but again if you will use my code SIRVK, SIRVK, then again you will be getting a discounted amount of 27,000. So you will be getting a 10% off, as well as I will provide a personal mentorship to you as well. So basically you are investing 37 rupees per day here and 60 rupees per day here. So if you are planning for it, purchase as soon as possible, because after 20th October these prices is going to increase and you may not get these things in these prices. Okay, so good evening Asis, good evening. So again I welcome you all to everyone. Okay, so basically this lesson is going to be very much focused, very much focused on numerical aspect of the resistance welding, what we have seen here. Good evening Subham ji, good evening. So before starting the numericals, whatever the concept I have told you in the earlier class, in the yesterday's class, let us rewind those things, let us visualize those things once again, so that when we are going to do the problems of resistance welding, you may not lag the concepts. Okay, so again basically in this resistance welding, most of the questions are asked from spot welding, so we are going to very much focus our things in the spot welding. Okay, so let us see what exactly happened in the spot welding. So we have seen that we are that would be like more than 1.5 hours. Okay, good evening Ajay ji, good evening. Okay, so see what is happening. We have also seen that when we are welding, when we are spot welding, so we are getting something like this. Okay, something like this. So this is your weld nugget. Clear? This is your weld nugget and this is your indentation. Fine, this is your indentation. So this is your indentation. Clear? This is again your indentation, and this is your height. Fine, this is your height. So this is your HN. So basically HN is what? HN is height of the nugget. Height of the nugget, it is also known as thickness of the nugget. We have also seen that its diameter is this. Okay, so it's D. So what is D? DN. So DN is what? Diameter of nugget. Now see my dear friend, if so, see what is this? This is the cylinder, right? So my weld nugget is in the form of a cylinder. So what I can write? The volume of the weld nugget would be pi by 4 d square into h. So this is going to be my volume of the weld nugget. So this is the first case, right? Now see, in questions, in GATE examinations, what you may find that they will tell you to assume the indentation is going to be 0. But see, since there is indentation here, so what you can write from this equation, see, this is also again the indentation. This is also again the same indentation. Clear? So what you can write from here, that if you want to find this height HN, so what you can write here is H is 2 times T minus of indentation. We have seen these things also. Okay. And one more thing that we have seen, that this diameter of this weld nugget is given by the Unwin's formula, that is 6 root T. That is 6 root T. Where T is what? T is sheet thickness. Sheet metal thickness. Okay. So what is this sheet metal thickness? This is the sheet metal thickness. Fine. So basically this is the idea, right? So I hope you got these things. Fine. Let us see in a gate examination what exactly a different thing has been given. So suppose what is given. Okay, so suppose what is given in gate, maybe they say that these are the sheet metals. Fine. So in this sheet metal, you are getting, so in this sheet metal you are getting the weld nugget which is spherical in nature. So they will mention that here the weld nugget was in cylindrical nature, right? So weld nugget was like this. Clear? So weld nugget was like this. So this is cylindrical weld nugget. And here this weld nugget is spherical in nature. So spherical. So for this kind of weld nugget, what would be my volume of the nugget? So volume of the nugget would be 4 by 3 pi r cube. Four by 3 pi r cube. Clear? Where r is this radius, and see we have also seen that r is the radius, so this is the thickness of the plate. So here r would be equal to thickness of the plate. So I hope these things are clear to you. If you, these things I have told you in the yesterday's class also. So in this, throughout the concept, if you have any problem, then ask with me, because we are going to solve a lot of questions from these concept. Okay. Good evening Ajay ji, good evening Subham Raj ji, good evening Shivam ji, good evening everyone, good evening. Okay, so I hope you understood these things. Let us move to our next concept. What are the next concept that we have seen? We have also seen that heat supplied is Hs, and this is equal to I square R T. Clear? I square RT, where T is the time in seconds, R is the resistance in ohm, I is the current in ampere. Okay, and we have also seen the melting efficiency. So before that, heat required to melt the metal, the sheet. We have also seen this is HM. So we have also seen that this HM is equal to you are actually requiring it. So MC delta T plus ML. We have seen these things, right? So what is the M? M is the mass. M is the mass. So you can find the mass of the weld nugget, mass of nugget. C is the specific heat capacity. Delta T is the temperature difference, that is the Tm minus of Ta. Clear? Tm minus of Ta, where Ta is ambient temperature and Tm is melting temperature. Okay, what is the L? We have also seen what is L. L is the latent heat. Now suppose, my dear friend, in the question you do not know the mass, but in the question density is given to you. So suppose density is given to you. So by using these formula, by using these formula of volume if the nugget is your cylindrical in nature, by using the formula of volume if the nugget is your spherical in nature, you can find the mass. Mass can be found out by applying the density is equal to mass into volume. So density into volume, okay. So let me write it like that. This is density, which is rho, into volume, which is V. Clear? Volume is volume of the weld nugget. So I hope these things, everything is clear to you. Now there is one more concept that is known as melting efficiency. Now what is the melting efficiency? You know that if you have done my classes, definitely you do not have any problem that melting efficiency would be heat required to melt by heat supplied. Okay, so this is going to be your melting efficiency. Now see, one another concept is there. What is the another concept? Suppose in this case, what exactly you are doing? See, so you are applying, so this is my plates. Okay, suppose this is my plate, and in this plate, you are applying the I square RT, which is heat supplied. Clear? So you are applying the heat supplied, that is I square RT. But out of these I square RT, there is only suppose this kind of weld you got, and here this welding is, if that weld you got is due to this HM, that is heat required to melt. Fine. So what you can see here, that you have given the HS amount of heat, but you actually required, but for the welding purpose only HM amount of heat is required. So there is another concept, that is heat dissipated heat dissipated to the sheet, or heat lost, it is also known as. So it is nothing but whatever the heat you supplied, that is I square RT minus of heat required for melting. So this is the heat dissipated. So I hope this everything is clear to you. So just let me know or give me the thumbs up, so that I can understand that whatever the concept that I have given in these two slides, that is totally clear to you, and you are now ready to solve any questions of this resistance welding. Just let me know so that I can start giving these questions. Just let me know very quickly. Just let me know, everyone. Just let me know these two slides, whatever the concept that I have written it in these slides, you don't have any kind of any problem. Okay, fine. So let's start our discussion to solve the question. So these, let me again tell you, these two things, these whatever the things that I have written here in this slide 1 and in this slide 2, this is only required to solve every questions of resistance welding. Clear? चलिए देखते हैं. Let us solve this question. I am giving you the time. Please try to solve this question, and then I will discuss it. Try to solve this question. I'm giving you a 1 minute time, and then I will discuss it. Try and tell me the answer. See, in this question Two sheets of 1.5 mm thickness are to be spot welded by supplying a welding current of this. So what is given? See, so there is a plate like this. Okay. So there is a plate like this, and in this plate, two sheets of 1.5 mm thickness. So this is sheet thickness. So this is T, and this is also T. So T is given as 1.5 mm. Now in these thickness, spot welded by supplying a welding current of 10,000 ampere. So can I say that it is a spot welding case? So the current supplied is 10,000 ampere for 0 0.1 seconds. Okay, so time is 0.1 seconds. Clear? 0.1 second. See, in this case, maximum indentation allowed on the sheet metal is 10% of the sheet thickness. So what is the sheet thickness? So sheet thickness is this. So this is the amount of indentation. This is the indentation. And this indentation is what? 10% of the sheet thickness. So can I write like that? 10% of 1.5. Clear? This is the indentation. This is the indentation. Density of the nugget material is 8 gram per centimeter cube. Let me write it here. Density of nugget is 8 gram per centimeter cube. Heat required for melting the metal is 1.38 kilojoule per gram. Heat required to melt. So what is this given? Is it given HM? HM is 1.38 kilojoule per gram. But see, my dear friend, that you have to observe here that see, this is in kilojoule per gram. So you need to get rid of this gram in order to get the HM melting heat required to melt the metal in joule. Fine. Calculate the melting efficiency. So you have to calculate the melting efficiency, and here the contact resistance that you have to take is 200 micron. So 200 into 10 to the power minus 6 micron. Clear? This is the resistance that has been given. Now see, so you got the weld like this. So you got the weld like this. Now see, what is the height of this weld? That is HN. So how you can find the HN? HN will be 2 times thickness minus of indentation. What is the thickness? Thickness is 1.5 mm. So I can write as HN is equal to 2 into 1.5 mm. What is the indentation? Is it 10% of 1.5? Yes. So I can write as 10 by 100 into 1.5. And from this, you can calculate the value of HN is 2.7 mm. 2.7 mm. Now you have found out the HN. How you can find the diameter of this weld nugget? How exactly you can find the diameter of this weld nugget? So can you find the diameter of weld nugget as dn is equal to 6 root t by the Unwin's formula? By the Unwin's formula, you can find the diameter of the weld nugget is 6 times root t, which is dn is equal to 6 into, what is the thickness? Is it 1.5? Yes, it's 1.5 mm. So I can get it. Just a minute. So it is 1.5. So I can get dn is equal to, dn would be what? Dn would be 7.348 mm. Okay, so we are getting these things. Now see, you require to find melting efficiency. And why I am finding this HN and DDM? See, because to find the, okay, someone has found the answer as 7.348. Okay, let's see. Let's see. Anybody else has also solved? No, your answer is wrong, Pankaj. Your answer is wrong. Okay, just have a look, check your mistakes, because I think you have done some minor mistakes. Okay, now see how you can find the melting efficiency. See, you can find the melting efficiency by using this formula: HM by HS, HM by HS, HM by HS. Fine, HM by HS. So see, to find the HM, you need mass. You need mass, correct? So to find the mass, you need the volume of the weld nugget, and that's why I have calculated the diameter of the weld nugget, and height of the weld nugget, so that I can calculate the volume. See how volume can be calculated like this. This is the volume. Clear? This is the volume. Fine. Okay. I understood, Pankaj. That is 7.348. You told about the diameter. Very good. So you have calculated this HN. You have calculated this diameter. So now what you can do it? You can find the volume of nugget. That is V is equal to pi by 4 dn square into hn square. So you can write pi by 4 into 7.348 whole square into height of the nugget is what? See, just now you have calculated 2.7. So just put it here. That is 2.7. This is going to be is equal to 114.49 mm3. So you have got the volume of the weld nugget. Clear? Now volume of the weld nugget is known. So can I find the mass? How can I find the mass? Density into volume of the nugget. What is the density? See here, the density is given here is 8 gram per centimeter cube. 8 gram per centimeter cube. Now, if I will convert this into the centimeter, so can I write like that? 114.49 into 10 to the power minus of 3 centimeter cube. So this is 8 gram per centimeter cube. Volume of the nugget is 114.49 into 10 to the power minus of 3 centimeter cube. So see here what is happening. This centimeter cube will get cancelled out, and you will be getting the mass. So mass would be 1.38. Just a minute. So mass would be 0.915 gram. 0.915 gram. And see here what has been mentioned in the question. In the question it has been mentioned that melting heat required to melt is 1.38 kilojoule per gram. Clear? Heat required for melting the metal is 1.38 kilojoule per gram. So can I write like that? HM was given as 1.38 kilojoule per gram, and to find the HMC, this is the mass. So can I write multiply by mass? So if I will multiply by mass, I will be getting the answer in the kilojoule. So this gram and this gram will cancel out, and I will be getting the answer of HM would be 1.26 kilojoule. Now see, I am done. I have successfully found the HM. To find the melting efficiency, I need HM and HS. So let us calculate this HS. How I can calculate this HS? By I square RT. Just apply these things. So your HS would be heat supplied, that is HS is I square RT. What is the I? What is the current? See, current is 10,000 ampere. What is the R? What is the R? This is 210 to the power minus 6. Minus 6. This is C ohm. Micron, right? So this is micron. Fine. So what is the time? Time is 0.1 second. Now can you find the answer? Can you find the answer? Just apply these things and find the answer. Tell me the answer of heat supplied. Tell me the answer of heat supplied. And you know the answer of heat required to melt. HM you know the HS. Now try to find the welding efficiency, melting efficiency. Now try to find it and tell me the answer. Now tell me the answer. I'm expecting your replies. Try to find it and tell me the answer. I'm not calculating, okay? Tell me the HS, and efficiency would be HM by HS. So tell me the efficiency. Now tell me. Now tell me. Now tell me the answer. 0.2 joule heat supplied. Very good. But that should not be in 0.2 joule. That should be. Please check your answer, Pankaj. Please check your answer. Your answer is like little bit silly mistakes you have committed. Okay, you have committed some silly mistakes. Check your answer. Very good. 2 kilojoule. So we have got the 2 kilojoule. Clear? We got the 2 kilojoule. So this is 2 kilojoule. Now see, HS is Ashish correct, Pankaj correct. Very good, very good. Everyone is giving the correct answer. So HM is 1.2 kilojoule and HS is 2 kilojoule. So I will put it like 1.26 kilojoule, right? 1.26 by 2 kilojoule, and this would be multiplied by 100 would give me as approximately it would be 63.16, isn't it? Any doubt throughout the question? Do you have any doubt? Any doubt throughout the question? Throughout the question, do you have any doubt? So see how we have solved this question. How we have solved this question and what are the concept that has been required. So see, this is height. So from this equation we have found the height. By using the Unwin's formula, we have found the diameter. Okay, and by these formula, that is the volume of a nugget. Now see, nugget can be of different types. I have told you nugget can be of different type. Either nugget can be of cylindrical or nugget can be of spherical. So based upon that, gate gate will modify only these things, right? So it will uh, get confused, it will make you confused by changing the nugget things, right? In one question, suppose they have given the cylindrical nugget, in another question they will give the spherical nugget. So based upon that, they will do the minor modifications and you have to very much cautious about it. Next, what we have seen this mass is equal to density into volume, and after that this heat supplied, how we can find the heat supply, and again last, melting efficiency. So I hope each and every steps, each and everything is clear to you. So if everything is clear to you, try to solve this question and tell me the answer. Try to solve this question and tell me the answer. Try to solve this question and tell me the answer. I'm waiting for your replies. If the indentation is high, then we can't assume cylindrical or spherical. So what is generally shape we should use if they don't talk about the indentation? Pankaj, what I can tell you, see, indentation will generally is very less. It is very less, right? It is very less. But see, generally in the gate you will get only two kinds of questions, that is these kind of question where you have specifically mentioned that nugget is cylindrical in nature and nugget is spherical in nature. So don't worry about the those things. बहुत ही क्लियरली मेंशन रहेगा क्वेश्चंस में, ठीक है, क्वेश्चंस में बहुत ही क्लियरली मेंशन रहेगा, आप उनको यूज करें, ठीक है. If the weld nugget would be spherical, definitely they will tell that this is a spherical weld nugget. Try to solve this question. Tell me the answer. Tell me the answer. I will give you 1 more minute and then I will try to solve it. Okay. So give a try and try to tell me the answer. Okay, let me explain this question because you all are taking a lot of time. Let me explain this question. See, two sheets of 3 mm thickness. Fine. So, okay, 508.71. No, that is wrong, Asis. That is wrong. Check your answer. Okay, so I'm giving you one like some 20 seconds more. Check your answers. That is wrong. Point 0.75. No, no. Okay, okay. No, Pankaj, that is not an answer. Okay, so see, everybody see here. See here. What is being mentioned? That two sheets of 3 mm thickness are to be spot welded by supplying a welding current of 10,000 ampere. So what is the welding current that you are applying? 150 mm cube. Very good, Shivam. Very good. Very good. Answer is perfectly correct. Shivam, perfectly correct. See, the in question current is given as 10,000 ampere, so that is 10,000 ampere. What is the sheet thickness? Sheet thickness is 3 mm, so that is 3 mm. Fine. Now see, so welding current is supplied for only 0.2 seconds, right? So it is supplied for 0.2 seconds. Heat dissipated to the base metal is 1000 joule. What is the heat dissipated? So heat dissipated. So heat dissipated is what? Hs minus of Hm, which is given as 1000 joule. Assume heat required for melting of metal is 20 joule per mm cube. That is in this question, Hm is given as 20 joule per mm cube. Now, if you would look closely, what is this mm cube? Is it volume? Now, to get the Hm in joule, I have to multiply with the volume and then I will get the Hm. So, just keep these things in your mind. Okay. Next, what? Contact resistance is 200 micron. So contact resistance is 200 into 10 to the power of minus 6 micron. Fine. So see, what is the volume of weld nugget? What is the volume of the weld nugget that you have to find? What is the volume of the weld nugget? So see, from this you have seen that HS minus of HM is 1000. What is the HS? What is the HS? That is heat supplied. So heat supplied is nothing but I square RT. What is I square? 10,000 ampere. So here would be 10,000 square. What is the contact resistance? 200 into 10 to the power of minus 6 ohm. What is the C time? Time is 0.2 seconds, right? So 0.2 seconds. So from here you would get the HS value as 4000 joule. 4000 joule. Now you know these things. You know these things that heat dissipated HS minus HM is 1000 joule and HS is 4000 joule. So from here you can find the HM. Okay, let's see. Let's see. So you know that HS minus of HM is 1000 joule and you know the HS. So HS minus of 1000 would be HM, and hence from here HM would be, what is HS? 4000 minus of 1000, which is H. So HM will be 3000 joule. Now see, you have got heat required for melting is 3000 joule, but in the question that was given that HM is 20 joule per mm cube. So see, given in question was what, like HM is 20 joule per mm cube. Fine. So see, this is the HM given. Now see, you know it answer in joule. So what is this? This is HM by volume, right? So what you will do, you will divide it. So 300 to find the volume. What you need to do? 3000 joule by 20 joule per mm cube and when you will divide it, you will be getting the volume to be 150 mm cube. Understood this question or not? I found the efficiency didn't read the complete question. Pankaj ji, that's why you should always and always attentively study the question, read the question very attentively, because sab kuch, everything is given in the question. If you could comprehend what is exactly being told in the question, you can solve any question. It is valid for any questions. Okay, so I hope you have understood these questions. You don't have any problem. Fine. समझ में आया ना क्वेश्चन सारा? कोई भी डाउट? एनी डाउट? चलिए, तो let us try to solve this question. Okay, I'm giving you time. Try to solve this question. In this question you have to find the melting efficiency of the process. Fine. So try to find this question answer and tell me the answer. Tell me the answer. Tell me the answer. So I'm waiting for your replies. Tell me the answer. Try to solve this question. Try to solve this question. Again, same concept. Concept is totally same. You have to find the melting efficiency. Okay, formula is same. Concept is totally same. Just study this, read this question very cautiously, and try to find the answer. Okay, let me see how many of you can give the correct answer. See, in this question, two metallic sheets of 2 mm thickness is given. Fine. So there is a two metallic sheets. Okay, that is of 2 mm thickness. So let me write like that. So there is a two metallic sheets. Okay. So there is a two metallic sheets in which you are doing the lap joint. Okay. It is mentioned are welded in a lap joint. Fine. By a configuration, by a resistance spot welding, in which you are applying a 10 kilo ampere of welding. But before that, what is the thickness? Sheet thickness is 2 mm. Sheet thickness is 2 mm. So can you write like that? This is the thickness. T would be 2 mm. This is also your T. So T is equal to 2 mm. So in this you are doing the spot welding. Fine. And what is the welding current? 10 kilo ampere. So welding current is 10,000 ampere. Fine. Next, what is the next thing? Welding time is 10 millisecond. So for the 10 millisecond period of time, you are applying the welding current. So time would be E is equal to time, that is 10 milliseconds. So 10 to the power minus 3, that would be milliseconds. That would be in seconds. Clear? Next, what? A spherical fusion zone. Most important thing is this. So here a spherical fusion zone is formed. Clear? Extending up to full thickness. Extending up to full thickness. Who was asking the question? Let me check it. Pankaj, you have asked that what would happen if indentation, these things are not given. See, this in this question it has been given that a spherical fusion zone is formed and it is extended up to full thickness. What is the meaning of the full thickness? This is the meaning of the full thickness, that your weld is like this. So this is the weld here, and it is extended up to full thickness, that is no penetration is there, right? No penetration is there. 70.38 Asis has told C. Okay, very good. Very good. Answer is correct. So 70.37, option C. Shivam, Asis, very good. You have correctly told the answer. Okay, let us see. So this is the case. So you have got the weld bead which is of spherical in nature. Clear? So you have got the weld bead which is of spherical in nature. So can I say that radius would be what? Radius would be is equal to thickness of the plate would be is equal to 2 mm. Fine. This is the radius. This is the radius. Okay. So ambient temperature is given as 293 Kelvin. Melting temperature is given as 1793 Kelvin. So let me write it here that ambient temperature. So T melting is 1793 Kelvin. 1793 Kelvin. T ambient is 293 Kelvin. Next, what is given? Density is given as 7000 kg per meter cube. So write it here that density is 7000 kg per meter cube. Next is what given? Next is given as latent heat of fusion, that is 300 kilojoule per kg. So what is the latent heat? So can you write latent heat is 310 to the power of 3 joule per kg, because it is given in kilojoule. right? Next was specific heat, it is in joule also. Fine, so it is in joule, so you did not have to worry about it. So C would be 800 joule per kg. Now see, you have to assume that contact resistance to be 500 micron. 500 micron. So what is your contact resistance? Resistance would be 500 into 10 to the power of minus of 6 ohm. Clear? Now see, and along the electrode sheet interface is 0, so you just have to assume these things. You have to find the melting efficiency. So how you can find the melting efficiency? You know that first of all you have to find the HM, then you have to find the HS. Okay, so what is the HM? How we can find the HM? See, HM is what? MC delta T plus ML. We have seen this formula. If you could not remember, see here, we have seen this. So can I write like that? This HM would be M C delta T plus of L. Fine. So let me write it here. So that is M C delta T plus of L. Now what is the mass? How you can find the mass? So mass is nothing but density into volume of this weld nugget. So this HM would be density. What is the density? You can find it by density into volume. Okay, so let us see what is the density. What is the density? 7000. So 7000 kg per meter cube. What is the volume of the weld nugget? This weld nugget is actually a spherical in nature. So that would be 4 by 3 pi r cube. That is, r is what? 2 mm. So you can write it 4 by 3 pi r cube. Fine. This is your mass. What is C? C is 800. Put it here, 800. What is delta T? So see, you have given the melting temperature as this, and this is your ambient temperature. So this is your delta T. So what is your delta T? 1793 minus of 293 plus of latent heat. What is the latent heat is given in the question? 310 to the power of 3. So put it here, 310 to the power of 3. And see, when you will calculate these things, you will get HM. HM would be is equal to 351.858 joule. So from here, you got HM as 351.858 joule. So you have found HM. Now what? You need to find the HS. You need to find the HS. So let us find the HS. What is the HS? So heat supplied will be what? This is HS is I square RT. So what is I square? See, again in the question it has been mentioned I square is this 10,000. R is what? R is this 500 to the power minus of 6. How much time period? Time period is given as 10 to the power minus 3 seconds. So put these things here. You will get as 10 into 10 to the power of 3 whole square into 510 to the power of minus of 6. This is the resistance into 10 into 10 to the power of minus of 3. So this is the time. So you will get this as 500 joule. So from here you got HS as 500 joule, and from here you got HM as this. So yes, that definitely that should be in 10 to the power minus 3. Definitely that should be in 10 to the power minus 3. You have to always convert the units. Definitely. Okay, thank you. So now this is going to be your HS. So you have to find the melting efficiency, and melting efficiency is HM by HS, and HM is calculated as 351.858, 351.858, and this is 500 joule. So you will get answer as 0.7036. So like this. So when you will calculate it in percentage, you will get as 70.37. So any doubt till now? Any doubt till now? Any problem my dear friends? कोई दिक्कत? क्योंकि these same types of question you are going to see throughout your like in gate also. Okay, so same concept, same things would be there. So if you have any kind of doubts, just let me know. Just let me know. Okay, understanding the concept or not? See, in this question was very much lengthy. It looks like that very big question is there. Baap re, kya hoga isme? So don't get panic. Don't get panic after seeing these questions. Believe in me. Believe in me. What is the concept that I want to tell you? Believe in me. These things. This is the slide 1 and this is the slide 2. So whatever I have written in these two slides, that would be enough to solve each and every questions of these things. Each and every questions of these things. I have very explicitly mentioned these things for you guys only, so that you may not face any problem while solving the questions. Okay? Chaliye. Badhiya, badhiya. Good, good, good. So let's try to solve some another question. Tell me the answer. For a resistance spot welding of 1.5 mm thick steel sheets, the current required is of the order. Tell me the answer. Latent heat plus heat raised to, yes, yes, yes. See, I have given the concept here. This is the latent heat. This is the latent heat, and this is the heat required to melt. Fine, Pankaj. I hope you got the ideas. Now tell me the answer. Tell me the answer. What should be the answer? D. Okay. Anybody else? Good, good. Ashish, Shivam, very good. Option would be D. Why option should be D? So always remember that in resistance spot welding, it is of order like 10,000 to 50,000 ampere. Okay. So basically they are in the order of 10,000. So definitely option would be D. Option would be D. So you can very easily understand that whatever the line and the sentences that I have written throughout this lecture, those things are very very much important, because the questions in the gate are asked from that things only. Okay, so जितना मैंने आपको बताया है, उस लाइन बाय लाइन को आप अच्छे से समझ लें, अच्छे से कोशिश करें उसको समझने का, and believe me, you will solve each and every questions of welding, casting, metal cutting. I'm pretty much sure you are solving these things and you are not facing any problem. Okay, chaliye, try to solve this question. Try to solve this question. This is the option A which is given here, 324. Okay, so option A is given as 324 here. This is option A. This is option B, option C, option D. Okay, tell me the answer. What exactly you are calculating, Pankaj? Pankaj, what you are calculating? Okay, you are calculating the previous questions. Okay, so I think there is a lag in your side, Pankaj, because you are giving the answers very less. Very good, very good. In a very, you are taking a lot of time. Okay, no problem, Pankaj. Keep trying. Very good, very good. You are solving in correct way. Try to solve this question of resistance spot welding and tell me the answer. Tell me the answer. Same concept, my dear friend. Same concept would be applicable. Same thing is there. Nothing new. But yes, there is some time of framing of the question is different. क्वेश्चंस को फ्रेम करने का तरीका यहाँ पे थोड़ा सा डिफरेंट है, हो सकता है, बट डेफिनेटली मैंने वो जो 2 स्लाइड्स में आपको कॉन्सेप्ट लिखा है, दैट दीज 2 स्लाइड्स आर मोस्ट इंपॉर्टेंट स्लाइड्स फॉर योर थ्रू आउट न्यूमेरिकल सॉल्विंग्स, राइट? Yes, Saurav Kumar. Yes, Saurav ji. Whatever the theory that I have mentioned, that is sufficient enough. Sufficient enough for gate preparation, as well as what I can say you that if you are in a BTech, definitely that every theory, each and every theory is more than enough. More than enough. If you can write it in your examination, you will get a very good marks. Yes, but Shivam. Okay, 344, 334. Good, good, good. 344. Okay. Option is C, right? Okay, good. Shivam has told very good answer. Very good answer. Anybody else? Anybody else? Anybody else? You are most welcome, Saurav. Okay, see here what is being mentioned in this question. In this question, it has been mentioned that resistance spot welding of 2 steel sheets is carried out in a lap joint configuration by using a welding current of 3 kilo ampere. Fine. So what is the welding current? Yes, Saurabh has also given the option C. Yes, yes, correct, correct. What is the welding current? Welding current is 3 kilo ampere. So I can write as 3 kilo ampere. Fine. Now see. It is given for only 0.2 seconds. So what is the welding time? Is it 0.2 seconds? Yes. A molten weld nugget of volume 20 cube is obtained. Now see, throughout these questions we have been calculating the volume. Either it is like a weld nugget is of spherical in nature or it is of cylindrical in nature, but see in this question explicitly mentioned that volume of the nugget would be 20 millimeter cube. Okay, the effective contact resistance is 200 micron, so you can write that effective contact is 200 micron. Okay, now see, the material properties of the steel is given as latent heat is given this, density is given this, melting temperature is 1520 degrees Celsius, specific heat is 0.5 kilojoule per kg Celsius, ambient temperature is 20 Celsius, and you have to assume 100% of heat transfer efficiency. Fine. So these things are mentioned. So you just have to calculate the heat used for producing the weld nugget. Now heat used to produce this weld nugget is what? This is nothing but hm. This is nothing but hm. So let us calculate this hm. How we can calculate this hm? How we can calculate this hm? Can we calculate that mass? It would be see, apply these formula only. See, just I have calculated mc delta t plus ml, that would be m c delta t plus of l. So apply this here, m c delta t plus of l. Clear? Now see, what is the mass that has been given? So can I write that hm would be mass would be density into volume, clear? And C, delta T would be melting temperature minus of ambient temperature, and L is the latent heat. So see, what is the density given in the question? So the density is given as 8000. So I'm just putting it here. So that is 8000 kg per meter cube, right? Meter cube. And see, volume of weld nugget is 20 cube. Okay, that is in meter cube, and the volume is 20 cube. So let me convert it in the meter. So definitely that is going to be 10 to the power minus 9 meter cube. Next, what is C? C is given here. C is given here. What is the C? Latent heat of melting. This is the latent heat which is given, L. And this is specific heat, that is 0.5 kilojoule. 0.5 kilojoule is given as the specific heat. So put it here, 0.5. So 0.5 kilojoule is there. So if I will convert it in the joule, so that would be 500 joule. Now see, what is the TM and TA? See, TM and TA is given as 1520 and 20. So 1520 degrees Celsius minus of 20 degrees Celsius. Now this is the, now what is, we are left with latent heat. What is the latent heat? It is 1400. It is 1400. Now see, this is in kilojoule. See, this is in kilojoule. So you just have to multiply it by 10 to the power of 3. Okay, so that would be your HM. And you will get the HM as 344 joule. Okay, so I hope you understood this question. See, Pankaj, basically in the resistance welding, we give, I think you have not attended my yesterday's class of the resistance welding. So I would I would tell you to watch my yesterday's video, so that you get the complete idea about the resistance welding and from where exactly these order is coming. Okay, because basically in the resistance welding we are very much concerned about the current, right? So from the current, heat is produced, and by using the heat and the pressure we are making the weld. Okay, so I would suggest you to watch my videos, so that you may not have any doubt throughout the process. Okay, so I'm pretty much sure that you understood this HM. Now see, so this is your option C. So now same question is there, and in this question you need to find the heat dissipated to the base metal. Can you find the heat dissipated to the base metal? Tell me the heat dissipated to the base metal, as well as tell me the melting efficiency also. I want these two answers: heat dissipated to the base metal as well as melting efficiency. Tell me these two answers. B, 16. Okay, very good, Shivam, very good. See, in this question, heat dissipated is to be found. So how you can find the heat dissipated to the base metal? How exactly you can find it? So see, heat dissipated is nothing but whatever the heat supplied minus heat required for melting. Fine. Now see, what is the HS? So you can find the HS. HS is I square RT. What is the I? See here, We have seen I is of 3 kilo ampere. Fine. So I can put it here, 3000 ampere. What is the R? See, R is 200 micron. So that is 210 to the power minus of 6 ohm. What is the time? So time is nothing. It is zero point 0.2 seconds. So put it here, 0.2 seconds. So this is HS. So HS would be nothing, but it would be 360 joule. Now see, HS is 360 joule. So can I write heat dissipated? Heat dissipated would be 360 joule minus of 344 joule. Clear? 344 joule, and that would be HD would be 16 joule. Now you all have not told me about the melting efficiency. Tell me about the melting efficiency. What would be the melting efficiency? Tell me the answer. Tell me the answer of melting efficiency. Tell me the answer of melting efficiency. Tell me the answer. So HM here is HM is 344. So I will just put it here, 344, and this is 360. Okay. So from here we know that 16 would be answer, and what would be my efficiency? 95.55. Very good, very good, very good. Ashish, Pankaj, very good. Shivam, very good. So we are getting as multiplied by 100, okay, to get it the percentage. So answer will be 95.5%. So now tell me, you have solved like 2 to 3 4 questions you have solved. Have you got some confidence in this chapter or not? You have solved some questions. So अब क्या आपको कॉन्फिडेंस आया या नहीं आया? अभी भी नहीं आया कॉन्फिडेंस? टेल मी. Now try to solve this question. Try to solve this question. Try to solve this question, okay? अब चलिए इस क्वेश्चन को सॉल्व करके मुझे आंसर बताइए. वेरी गुड, वेरी गुड, वेरी गुड. अभी और आधे घंटे आप मेरे साथ बने रहें, मैं आपको और भी तरीके का क्वेश्चंस करा रहा हूं. एंड डेफिनेटली आफ्टर दिस सेशन यू विल बी प्रीटी मच वेरी मच कॉन्फिडेंट एंड यू कैन हैंडल एनी क्वेश्चंस ऑफ रेसिस्टेंस वेल्डिंग, most specifically of the spot welding from the previous year. You can solve it. You can very easily solve these questions, okay? I'm pretty much sure. Try to solve this question and tell me the answer. Tell me the answer. Same concept. Concept is totally same. Concept is totally same. Concept is there. You just have to apply those concept whatever you have learned in this question, okay? After a minute I will try to explain these questions. Okay, C. Very good, Shivam. Very good, Shivam. Anybody else has got the answer? Anybody else has got the answer? Solve this question. Very easy question is there. Very easy question, as well as whatever the concept I have told to you, that will be enough to solve this question. Okay, same question is there. Concept पूरी तरह से same है. थोड़ा सा क्वेश्चन को कॉशियसली पढ़ें और क्वेश्चन आपसे बन जाएगा. So I'm giving you like 20 seconds and then I will start to solve this question. Okay, okay. See in this question what is being told. A spot welding of two 1 mm thick sheets of steel. Fine. And the density of this is given as 8000 kg per meter cube. So there is a two 1 mm thick steel sheets. Fine. So carried out successfully by passing a certain amount of current for a 0.1 seconds through the electrode. So by a certain amount of current, so definitely you have to find the current. Okay, okay. So the resultant weld nugget is in the formed is 5 mm in diameter and 1.5 mm thick. So what is the 1.5 mm thick? That is given as height of the weld nugget, and this is the diameter of the weld nugget, right? So this is the density given. This is the 0.1 second. This is the time given. Clear? Okay. Now, if the latent heat of fusion of the steel is 1400, so this is the latent heat of fusion given. This is the resistance is given 200 micron. You have to find the current. Pankaj has told A. No, Pankaj, your answer is wrong. I think you have done some mistakes. Understand, please, everyone. I request you, please see here and try to understand this concept. So there is a spot welding. So there is a spot welding, and in this spot welding, you have got the weld like this. So in this spot welding, you have got the weld like this. Okay, so you have got the spot welding, you have got the weld like this. Okay, so this is the very good, Ashish, very good, correct answer. So this is the spot welding. So in this spot welding, what is happening? This is the height. This is the height of the nugget, and this is given as 1.5 mm, and the diameter is given as 5 mm. So this is the diameter. Diameter of the nugget is 5 mm. Clear? So this is basically, these things are given. What is the thickness? So the thickness is given is somewhat around, thickness is given as 1 mm. Thickness is given as 1 mm. Clear? So thickness is 1 mm. Density is 8000 kg per meter cube. And what is the time? That is 0.1 second. So time required is 0.1 second. And resistance is 210 to the power minus of 6 ohm. 200 micron is given. Fine. Latent heat is given as 1400. So write it here. Latent heat is given as 1400 into 10 to the power of 3, because it is in kilojoule. So you have to convert in joule per kg. Now see, in this question you have to find the current, and nothing has been mentioned about the efficiency. Nothing has been mentioned about the efficiency. So what you can assume? So what you can assume? Melting efficiency to be 100%. So assume melting efficiency to be 100%. And what is the melting efficiency? Is it HM by HS? So if it is 100%, definitely it is going to be 1. Therefore my HS would be is equal to HM. HS would be is equal to HM. Now what is the HS? What is the HS? See, heat supplied is nothing but I square RT. And what is the HM? What is the HM? See, HM is nothing but MC delta T plus of ML. Now see, again in this question there is nothing been mentioned about the C capacity, heat capacity, and the change in the temperature. Nothing has been mentioned about. Only the mention in this question it has been mentioned if the latent heat of fusion of steel is given like this. So you just have to consider this. So see, in the gate they understood your purpose, and to get to have your calculations very much simple, they have assumed this to be 0. So just these things would be 0. So now your calculation is very much simple. You got I square RT, that is equal to ML, and see, I you don't know, R is what? See, R is 200 into 10 to the power minus of 6, right? See, this is the R. So just write it here, 210 to the power of minus of 6. Clear? So this is the R. Now see, next what is there? What is the T? It is 0.1 seconds. So put it here, it is 0.1 seconds. This is equal to what? This is equal to M into L. This is equal to M into L. What is the mass? See, mass would be density into volume, and volume would be what? Pi by 4 d square into h. Assume to be this weld nugget to be cylindrical, right? So what you can write has 8000 into pi by 4 into d square. D square is 5 into 1.5. Now see, these 1.5 is also in mm, d is also in mm. So to convert these things, this is in h. So to convert these things into meter, I have to multiply by 10 to the power minus of 9, and this everything would be in meter cube. Clear? Now see, this is what? So this is your density, okay? Don't forget it. This is your density, and this whole term is your volume. Clear? So from here you have calculated the mass. So just you have to multiply it by the latent heat. So you just have to multiply by the latent heat, and latent heat is 1400 10 to the power minus 10 to the power of 3. See the latent heat, it is in joule per kg. So from here you will calculate the value of I, and the I would be 4060 ampere. समझ में आ रहा है या नहीं आ रहा है? समझ में आ रहा है या नहीं आ रहा है? I is equal to 4060 ampere, and the option would be C. Clear? Option would be C. Okay, Pankaj. So, Pankaj ji, I am pretty much sure that now you are understanding that आपका mistakes कहाँ पे हो रहा था, है ना? So now you can very easily. So those who have those who are committing the mistakes, now they can properly analyze that what exactly the mistakes that I was committing and what is the right method. So my intention is not to solve like 2 or 3 or 4 questions in this throughout the session and then go. No, my intention is that to develop the thought process. Whenever you are seeing a question, what should be your thought process after saying the question? What exactly should be a proper step? And these things, development of these things would be there. अगर ये develop कर गया ना आप में, तो you can very easily solve the question. Yes, Ashish. Yes. See, Ashish, in this question, what exactly I would tell you, see, there was nothing mentioned about the there is sensible heat is given, right? Nothing has been mentioned about, because we know that, see, we know that this is the sensible heat part. This is a sensible heat part. So whenever there is a sensible heat and there is a latent heat, so whenever the sensible heat part is not given, so you just neglect it, right? And moreover, nothing has been mentioned about in the words like sensible heat or something like that, so you just have to assume this to be 0. So I hope, Asis, your doubt is cleared. Okay, so let's move to the next question. Try to solve this question and tell me the answer of again a resistance spot welding. I'm giving you some time and tell me the answer. Again the same question, very easy question. Like you can solve it in 20 seconds. 20 seconds is more than enough to solve this question. Try to solve this question and tell me the answer. Very fast, very easy question is there. Very easy question. Try to solve it. Now see in this question what second is given, what second. Okay, so what is the meaning of what second? See, what second. So if you would properly analyze this, what is what, this what is actually, this is a joule per second and this is the second, so there is a second, so these will be cancelled out and watt per second is nothing but it is joule. So in this question they have tried to confuse it, so don't confuse it. This watt per second is nothing but it is in joule. Okay, now tell me the answer. Very good, Asis, Shivam, very good. Answer is A. Very good, very good. So see, from this question what we can understand, resistance spot welding is performed on the two plates of 1.5 mm thickness with a 6 mm diameter electrode using the 1500 ampere of current. So what is the amount of current that is required? 15,000 ampere for a time duration of 0.25 seconds. So time duration is given as 0.25 seconds. Assuming the interface resistance to be this much, so what is the resistance? This is 0.0001 ohm. The heat generated, what is the heat generated, my dear friend? Heat generated is nothing but heat supplied, and this is I square RT. I square RT. What is I? That is 15,000 whole square. R is 0.001 and T is, so T is 0.25 seconds. So when you will solve it, you will be getting as 5625 joule. And see, 5625 joule. So don't worry about these things. Option would be A. That's a weird way to give options. Yes, Pankaj, that's a really a weird way, but definitely these weird way sometimes works. These weird way sometimes works. These IIT professor of IITians like IIT's professor are very much clever, very much clever. They will लाइक वो बहुत ज्यादा अल्टरेशंस नहीं करते, बहुत ही छोटा मोटा बेसिक्स अल्टरेशंस चेक करते हैं. सी बाय अल्टरिंग दीज ऑप्शंस, by altering this option, what was their intention? What was their intention? See, their intention is not to get the answer. See, they were not interested to get the answer 5625. They were interested that whether this dimension is clear to you or not. They are interested to know that whether this dimension is clear or not, whether your basics is clear or not, whether your basics is clear or not, right? So this is the basic. So you're not checking that you just calculate. Anybody can calculate and get the answer as 5625, but knowing the basic is very much important, and they have checked your basic. Okay, so okay, now let us try to solve this question. Okay, so this question I would solve in the next class. Okay, so this is a question of a flash butt welding. So tomorrow I will explain the concept of flash butt welding, and then I will explain this question. Okay, so don't do it now. Do this question. Try to solve this question and tell me the answer. Try to solve this question and tell me the answer. Okay. I am expecting your replies. Okay. So there is another question of spot welding, like two steel sheets of 2 mm thickness, right? So each of 2 mm thick, carried out successfully by passing the current. So current is given. So he's here. The current is given. Time is given. This is the thickness is given. Clear? The resulting weld nugget formed by the sheets of 5 mm in diameter. So this is the diameter of nugget is given. Assuming the cylindrical shape of the nugget. See, they have clearly told that to assume the cylindrical shape of the nuggets. So you have to find the thickness of the nugget. So what is the thickness of the nugget? It is the height of the nugget. So find the height of the nugget and tell me the answer. By using these data, try to find the height of the nugget and tell me the answer. B. Okay. Anybody else has solved or not? Anybody else have solved or not? Very easy question. You can solve it. Each and every data is given in this question. Just read the question properly and definitely you will be able to solve this question. Okay. So let me solve it. Shivam, you have correctly told the answer. Very good. So see, in this question, the thickness is mentioned, right? So plate thickness is 2 mm. Successfully by passing the current. So what is the current that has been passed? Current is 4 into 10 to the power of 3 ampere. Clear? Next, what is mentioned? 0.2 seconds. So for a time of 0.2 seconds, the current has been passed. The current has been passed. Diameter of the weld nugget is given as 5 mm, and height of the weld nugget is being asked. Height of the weld nugget is being asked. So see how you can find it. Again, since nothing has been mentioned about the efficiency, assume melting efficiency to be 100%. Melting efficiency to be 100%. Very good, very good, Pankaj, very good. So melting efficiency would, if melting efficiency would be 100%, definitely melting efficiency is what? HM by HS. This is 1, so definitely HM would be HS. Clear? HM would be HS. Now see again, there is nothing mentioned about the, here the latent heat of fusion is given, that is L is given. Clear? Effective resistance, that is R is given, L is given. Clear? Density of steel is given. So there is again nothing has been mentioned about the C, specific heat capacity. So what you can write here, so HM is what? See, HM is MC delta T plus of ML, and this HS is what? I square RT. So there is nothing mentioned about these things, so you will just assume it to be 0 and see, you can find the answer. You can find the answer. Now see, what is the mass? What is the mass? So density into volume. By using the dn and the hn, you can find the density. So let me write it here. This is going to be ml. is equal to I square RT. So what is the M? So density 8000 kg per meter cube into pi by 4 d square into h, 5 square into h. So this is the density. Clear? Because it hasn't mentioned that nugget is cylindrical shape. Clear? Now what is the latent heat? It is 1400 kilojoule. So it is kilojoule. So you have to convert in joules, right? So how you can convert it? Multiplying by 1000. 1400 into 10 to the power of 3 joule per kg, and this whole thing is in kg, right? So kg can cancel out. This is going to be joule. Now what is the I square RT? See, I is given in the question is 4 into 10 to the power of 3 ampere. So that is 4 into 10 to the power of 3. I square is given. Now what is the R? 210 to the power minus of 6 ohm. This is the R. Clear? This is the R given. See, 200 microns. Now what is the T? It is 0.2 seconds. It is 0.2 seconds multiplied by 0.2 seconds. And from here, only thing that is unknown to you, is the HN, and everything is known to you, and you can calculate. Now you can calculate, and from here you will get the height of the weld nugget to be 2.91 mm. So option would be very good, Ashish, very good. Your answer is also correct. तो समझ में आ रहा है ना चीज कितना आसान क्वेश्चंस होता है. The questions from resistance welding is very easy. So like I don't know how many of you are doing these questions for the first time. So like एक हैवोक होता है, एक डर सा होता है कि रेसिस्टेंस वेल्डिंग का प्रॉब्लम सॉल्व नहीं होता है ना. दिस इज द मेंटेलिटी. सो आफ्टर अटेंडिंग दिस लेक्चर आई एम प्रीटी मच श्योर अगर ऐसा मेंटेलिटी आपका भी होगा तो अब आपको बहुत कॉन्फिडेंस मिल रहा होगा रेसिस्टेंस वेल्डिंग के क्वेश्चंस को सॉल्व करने में. ठीक है, चलिए एक और क्वेश्चन सॉल्व कर लिया जाए बिफोर गोइंग इनटू द क्वेश्चंस. सी, इन रेसिस्टेंस सीम वेल्डिंग द इलेक्ट्रोड इज इन द फॉर्म ऑफ ए. टेल मी द आंसर. टेल मी द आंसर ऑफ दिस क्वेश्चन. टेल मी द आंसर ऑफ दिस क्वेश्चन. आई वांट द आंसर. आई वांट द आंसर. इन रेसिस्टेंस सीम वेल्डिंग, सर सीम वेल्डिंग में कैसा इलेक्ट्रोड यूज होता है? टेल मी, टेल मी, टेल मी. दिस इज अ स्पॉट वेल्डिंग. Okay, just a minute. So this is for a spot welding. This is a seam welding, and let me write it for a projection. Tell me, for a resistance seam welding, electrode is in the form of? Don't worry, Pankaj, you can watch my all the series I have started for you guys only. I have started the series of production engineering. I have full course I have made. So I have just completed the metal cutting part, the casting part, and after 20th of October I will be finishing the welding. So your welding will also be over. So you can watch my each and every videos so that if you have any doubt, definitely your doubts would be cleared by watching my lectures. Tell me the answer. In resistance seam welding, okay, so Ashish is telling as D, circular disc. Okay, anybody else? See, we have seen that in spot welding my electrode looks like this. My electrode looks like this. Fine, so this is the electrode. This is how the electrode looks like. Okay, but in the seam welding my electrode is like this. It is in the form of a circular disc. Clear? This is in the form of a circular disc. And in projection welding my electrode is like this. like this. And this is, so the name is, this is known as, this is cylindrical, this is cylindrical. Okay, seam it is of circular disc, and it is of a flat electrode. So I hope you have got the basic idea. If you have attended my yesterday's video, so you don't have any problem, but still I have just given the explicitly things, that in the spot welding you will be getting a cylindrical electrode, and in the seam you will be getting a circular disc electrode, and in the projection you will be getting a flat. So answer is going to be circular disc. Now try to solve this question and tell me the answer. Now again try to solve this question and tell me the answer. This is going to be your the last question of the entire session. Okay, so have some energy and solve this question. Solve this question and tell me the answer. This is the last question of the session. Solve this question and tell me the answer. In this you have to calculate the percentage of the total energy utilized in forming the weld nugget. So percentage of total energy utilized. So what is they are telling about? They are telling about the total energy utilized, percentage of total energy utilized. So they are exactly telling about, they are telling about the melting efficiency in the percentage. So in this question it has been asked to find the melting efficiency in the percentage. Fine, now try to solve this question. I'm pretty much sure everybody will tell me the answer. Everybody will tell me the answer. I'm waiting for your reply. First of all, calculate the heat supplied by Hs is equal to I square RT. Then just calculate the heat required to melt, right? So Hm, you calculate the Hm, and after calculating the Hm, divide it, that Hm by Hs, and then by you will be getting the melting efficiency. Okay, just to try to solve this question. 35. No, Shivam, no. Kindly check your answer. Could you please check your answer? I think you have done some silly mistakes. 35 would not be the answer. $71.16. Again, no. How you people are calculating this? How you are calculating this? Okay, give a try, give a try. I'm again giving you like a 1 minute, and then I will solve this question. Because if you will solve in your own, then you will understand what exactly you are doing the mistake. Very good, Anirudh ji. Very good, very good. You have told very correct answer. That is 50.6. Good, good, good. Your answer is correct. See, in this question, aluminum strip of 2 mm thickness. Fine. So thickness is what given? Thickness is given as 2 mm. are joined together by resistance spot welding process by applying electric current of 5000 ampere. Yes, now again Pankaj, very good, answer is correct. See, electric current is what? Electric current is given as 5000 ampere for a 0.15 seconds. So again time is 0.15 seconds. The heat required for melting aluminum is this much, 2.9 joule per mm cube. So see here, I can write HM is what? 2.9 joule per mm. See, the problem is that HM should be in joule, but HM should be in joule, but it is here the mm cube is there, that it is divided by the volume. So if I would multiply this HM per unit volume by the volume, then definitely I will get the HM in joules. Okay, so just keep these things in your mind whenever you see these things. Okay, next is what? The diameter and the thickness of the weld nugget is 5 mm and 2.5. So what is the diameter of weld nugget is 5 mm. Thickness of the weld nugget, so thickness of the weld nugget, that is height of weld nugget, is 2.5 mm. Again, assuming the electrical resistance contact to be 75 microns, so just assume that R to be 75 into 10 to the power minus of 6. Sorry, it should be minus of 6. So that is minus of 6 ohm. The percentage of total, so you have to find the melting efficiency. So again, you have got some this kind of spot welding is there. So in this spot welding, this is the welding that you have got. This is the height of the weld, and this is the diameter of the weld. Fine, diameter of the nugget. So from here, what you can calculate, first of all, calculate the HS, total energy supplied. Okay, so total energy supplied. So total energy supplied, HS would be I square RT. So what is I? See, I is given as 5000. So put it here. I square R. So R is given as 75 micron. T, time is given as 0.15. So 0.15 is given. So put it here. That is 0.15. And you will get the HS value as HS is equal to as 2.9. So HS is what? That when you will calculate it, you will get as 281.25 joules. Okay, 281.25 joules. Clear? Now see, this is the HS that you got. Now how you can calculate the HM? So see, HM, you know that it is in joule per mm cube, that is divided by the volume. So you have to just calculate the volume. And how you can calculate the volume? Remember again, same thing. You know the diameter of the nugget, you know the height of the nugget. So since the nugget is assumed to be in the cylindrical, so volume would be what? Pi by 4. Diameter of nugget is square. Height of nugget is height of nugget. Clear? So from this you will able to solve this question. So from here, what is the volume? So volume would be V is equal to pi by 4 into 5 square into 2.5. And see, these all are in mm, so you will get the volume would be in mm, that is 49.087 mm cube. Okay, so you will get the answer in volume in mm cube. Fine, तो mm cube में आपको मिल गया वॉल्यूम. अभी now what you got, the HM is 2.9 joule per mm cube. So HM is, that is HM per unit volume, it is given as 2.9 joule per mm cube. Now to find the HM, what you will do it, you will multiply 2.9 per joule per mm cube into 49.087 mm cube, and by this you will get that mm cube and mm cube will get cancelled. You will be getting the answer in joule, and from here the hm you will be getting is 142.353 joules. Clear? Now see, now see, you have calculated this hs you have calculated. Now you have calculated this hm also, you have calculated this hm also. Now what you need to do, my dear friend, you need to be very much, now you get relaxed. Why? Because everything is here. hm by hs multiplied by the 100, because you have calculated the hm and the hs. What is the hm? hm is 142.353 joules and hs is 281.25 joules into 100, and c you will be getting as 50.59%. Okay. uh, Alchemist, what I can tell to you is, see, you can take the screenshot. See, only 2 slides is there, only 2 slides is there. I have wrapped up each and every concept in these 2 slides only. Okay, so take the screenshot of this slide and take the screenshot of this slide. Only these 2 screenshots would be enough to solve your questions. And let me tell you, since you are from the pi stream, I am pretty much sure you will also solve every questions in the pi, because I know in the production there is like little bit tougher questions are asked from the mechanical, but I'm pretty much sure after watching my lectures you will able to solve every questions. Okay, so till now this was all about from my parts for today's session. I think you all have enjoyed my session and gained knowledge, as well as if you really have faced a lot of problem in the welding. So after this class, I'm pretty much sure your resistance welding part is like very much you gain a lot of confidence in this topic, in this subject. And if you gained this confidence and this topic, you have really enjoyed it, do like this video as well as share this video to your friend circle, in your friend circle as well as into your peers, so that they will also get benefited and you are also getting benefited. Okay, now what you can do it, if you are planning for a plus subscription, use my code SIRVK, SIRVK, and you will be getting a 10% off in the subscription, as well as I will provide my personal mentorship to you also. So do share these videos, like these videos, and if you have any doubt throughout this session, do let me know so that I can clear your doubt at the same time. And if you don't have any doubt, then also do let me know. Then I will end the session. Okay, then I will end the session. So I'm open for your doubts, my dear friends. चलिए, किन्हीं को भी कोई डाउट है तो मुझे बता दे। आज का क्लास मजा आया कि नहीं आया? कुछ सीखने को मिला कि नहीं मिला? कुछ सीखने को मिला कि नहीं मिला? I have tried to covered almost different types of questions in this session, and definitely आपको बहुत कुछ सीखने को मिला होगा. Most importantly, again I am telling you, remember these things. Okay, the slide 1 and slide 2, अगर ये दो चीज आपको अच्छे से याद है ना, जितना भी चीज मैंने लिखा है, देखिए याद नहीं करना. सी, डोंट रट्टा नहीं लगाना है. डोंट रिमेंबर लाइक दिस, लाइक मग अप. नो, मगिंग अप इज okay. In manufacturing we have to mug up a lot of things. Definitely I agree with you, but see, you have to mug up by understanding the concepts, and I'm pretty much sure that you have understood the concept, the science behind it, and after that if you could mugging up would be very much easier for you, है ना. समझ के रटने में आसानी होती है और ऐसे रटने में बहुत दिक्कत होता है. फाइन, तो चलिए, थैंक यू सो मच. So I think you don't have any doubt. So thank you so much for your active participation. And if you are planning for the plus subscription, use my code SIRVK, SIRVK, and you will be getting a 10% off. Yes, very good Pankaj. See, that's why I give some time before solving the question, because अगर मैं आपको solve करके question दे दूँ ना, तो you will not be able to understand what exactly you are committing the mistake. But if I will give you 1 minute or 2 minutes of time, definitely in that time you will be identifying where exactly you are doing the mistakes, and then when I will solve the question, each and every doubts will be cleared at the same time. Fine. Okay, so thank you so much. You have been very wonderful to to make this session to be very much interactive. Thank you so much for your active participation and making this session to be interactive. Thank you.